Ladies, this is section 2.3 in your notes, and we are under Goal 2, Example 2, find the zeros of polynomial functions that are difficult to factor or either we cannot factor. So if we look at this 4-term polynomial, I'm going to first try to factor this, and I'm going to check for a GCF with each term, and there is not a GCF. And then if we tried to factor by grouping, we would take x squared out of this term, and that would leave us with 3x plus 2. But there's no common factor to take out of 19x plus 6, which would reduce to 3x plus 2. So we can't factor, so we have to find our possible rational zeros. Remember, our possible rational zeros, p divided by q, we're looking for factors of p. Recall, p is the constant. Here our constant is 6, divided by factors of our leading coefficient, which is 3. I know that the factors of 6 are positive 1 and positive 6, and negative 1 and negative 6. So plus or minus 1, plus or minus 6, also positive and negative 2, and positive and negative 3. The factors of 3 are positive and negative 1 and positive and negative 3. So our possible rational zeros are 1 and 1/3, 6 and 6/3, which is 2, 2 and 2/3, and then 3 and 1. So we have a multitude of possible roots. Remember, all positive or negative. So remember, we could plug each of them into the function until we found a remainder of 0. But I'm giving you permission to graph these on your calculator. So let's graph this function now. And I see that it is degree 3, and I do have 3 real zeros. So I don't have to worry about any irrational zeros. All right, so let's compare our possible rational roots to the zeros that we see on the screen. This appears to be negative 3, so let's check that out. Menu, trace, and I'm going to type negative 3 in. And I see that I have an ordered pair of zeros. So negative 3 is a 0. If I continue to the right, it looks like this could possibly be my 1/3 or my 2/3 solution, possible rational zero. So let's try 1/3. 1 divided by 3. And it looks like, remember we said recently that 5.6, when we have times 10 to the negative 12th power, we had a value that was very, very close to 0. So we can go ahead and say that that is 0. And you can adjust by moving your arrows left and right, and that does tell me that that's a 0. So right now I have negative 3. I have positive 1/3, and then the final root looks like positive 2, and let's double check that. And it is also a root. So in this case, I have 3 zeros, negative 3, positive 1/3, and 2. And I chose this example to point out to you that your zeros will not always be integer values. So it's important to double check where you have fractions and make sure that they match your rational zeros. If you prefer to use a table rather than the graph, you can open up a table under Menu, Table, Split Screen. But notice here the table has already been completed for you, and so that works fine for your integer values. For example, like negative 3 and 2, but that does not work for the fractional values. So to change the settings so you can enter fractions, you would go under Menu, Table, edit table settings, and go under independent and change that to ask. That means you get to tell the calculator what the x-coordinate is. So now I'll type in 1/3, and it does give me a y-coordinate of 0. We can double check -3, and we can double check 2. And those are all zeros.